This is John Tucci with Lake Savers and Aeration Tech with a little example of how tough it can be sometimes to save a lake. We're at one of our projects in the Midwest, and you can see the lake down 100 feet plus elevation below where I'm standing now through the trees and past that house. And I'm standing up here because it turns out that we had to come all the way up here to discover a major source of nutrient inputs and pollution entering this lake that has been responsible for our inability to get control of the Eurasian water milfoil growth in this south end or south bay of this lake. What was happening is that this road that you see sloping down, this gravel road, was effectively a river every time it rained, and there is a storm drain system at the end of this road that would carry that water with all the gravel and even erosion off of these banks over here off of this piece of land to your left right into the lake. And we have done measurements on the storm water coming in off of this road, and they are before we did this mitigation work, it was 10 to 20 times higher depending on the severity of the rain than what you want coming into the lake. And we would get plumes of what we call chocolate milk, or highly sediment laden and nutrient laden water spreading out acres and acres beyond the storm drain entry that you'll see in a few minutes in this video. I'm going to turn around now to show how creative you have to be sometimes to solve these problems. You can see we've done some work on some storm drains and re-ran culvert pipes under this road so that all the way down, so that we could avoid erosion of the road into the lake itself. But we found that there was so much volume of water that our system here couldn't handle it. So what you're looking at here is what is hopefully our ultimate solution for this this particular problem. The source of the water coming down the road I just showed you was actually this upper road coming all the way down from that side and all the way down from this slope, and using our road as a river to send water to the lake. So what we did was brought in some gravel and regraded the road, so that we're now sending all of that storm water into a very large, very deep dry well pit that we've dug, and we're now protecting from filling up with gravel with our silt socks. So those will let the water through, but hopefully pile up the gravel as it rains, so we don't fill up this dry well too fast with gravel. And we've already tested this. We got most of this done yesterday, right in time to battle a 1-inch thunderstorm last night. And this dry well handled a 1-inch rain event with no problem at all. In fact, as we go down the bottom, I'll show you how well it did in terms of preventing any water from getting down from this storm drain system and actually reaching the lake. We've got a whole series of filtration steps as we come down this project that I'll show you in a minute. And between what we've done with the dry well behind you and the filtration on the storm drain, we handled a 1-inch rain last night and were able to filter all of the water coming from this storm drain system and getting it to go into the ground so that it actually never reached the lake over land. Just tremendous accomplishment. We're hopeful and confident that this same system can handle even bigger rains, and we may unfortunately get to test that here in the next few days based on the weather forecast. So I'm going to walk you down here just to show you what can be done to storm drain catchments to help prevent them from filling up with gravel using our silt sock technology. And here we've got a pretty severe slope of which is going to take some water into this storm drain catchment, and so we've got it very well protected in terms of trying to break the flow up several times and drop out that gravel before the water drops into our storm drain. On this side, in order to handle the flow, and in this basin we've actually got a separator system underground that allows us to filter out any gravel before the water goes. It's a newer system, so we've decided to leave this one open on the front side so that it can handle a little bit more volume. So we'll walk you down here in a minute and show you some of our the beginning of our filtration stages where this water comes out of the ground. So down here you can actually see we're taking the water from the top, from our storm drain catchment underground, and we're actually going to bring it back up above ground before we send it through the final stage that starts heading it toward the lake. We're doing that so that we can actually set up a series of filtration cells, and you can see the fines that are building up in these little filtration pits. We shovel these out periodically, but not trying to get all the tiny particles out, but you can see that real fine material caught behind our filtration socks. We're catching that every time it rains, and more of it as we go down these series of filtration cells. You can see all the fines that get trapped out. We've actually shoveled these out after last night's rain, and what you see is just what's left at the bottom that we couldn't completely clean out. So there is some maintenance when you do this kind of work, but believe me, it's a lot easier cleaning out these little catches than allowing this very nutrient-rich sediment from getting to the lake and then having to deal with the problems it causes in the lake. Here's our final cell, and you can tell that those fines are gone, and really here we've got a clean catch. So by the time the water reaches this stage, it's pretty clean. We're going to send the water again underground to another filtration device that we've created in a minute. So here's where this stormwater pipe comes above ground again, and you can see we've got what we call a pipe sock or a filter sock installed in this part of the project, and we've got 6 different filtration cells inside of this sock. And at each stage we can see during real heavy rains we still get some sediment past our filtration above, and this sock is designed to 30 foot of filtration with 6 different filtration cells inside. This filter sock is designed to continue to catch as much of those fines and sediment as possible, and even start to filter out some of the dissolved nutrient. Now the water then continues to flow down this open culvert down to a pipe that you can see through the growth here, and that pipe travels about another 100 feet to the lake, and I'll take you down there to show you our final stage of filtration for this project. So here we are at the end of the project. We've got about a 30-inch outfall pipe, and this is where all of the water from this storm drain system was being dumped into the lake, along with all the nutrients and sediment along with it. And so the land I'm standing on was actually built by dirt and gravel and sediment being delivered to the lake from this outfall pipe. And we now have repurposed this spit of land here into a large dry well catch. And so I'll take you up to the pipe here to show you what we've got going on. We've actually got a wall of filter socks here, so as whatever water and sediment makes it this far down through our system is going to hit that wall of filtration, the sediment should drop out and the water should slowly filter through this dry well filtration cell that's got multiple layers of filtration built into it and built down to a depth. So what we're trying to do here is take all the water, filter it, and percolate it into the ground so that none of it actually flows directly into the lake. And we've been through a pretty good test so far. We had a 1-inch rain last night, and we handled all of that without a problem at all. We'll certainly get bigger rains than that, but based on our 1-inch, pretty fast 1-inch rain test that we had with a thunderstorm last night, we're pretty confident that this catch will really do a great job of preventing any chocolate milk, any water laden with sediment getting to the lake at all. And if you look out into this bay, prior to building this catch, a 1-inch rain would have delivered enough chocolate milk to make this whole part of the bay, about 10 acres or so, brown with that sediment and nutrient enriched water. And we've tested the water coming off this system, and even though there's not a lot of farmland or fertilizing or what have you going on, the soils around this part of the lake are very rich. And so as we were getting that erosion, depending on the severity of the rain, we have measured phosphorus levels 5, 10, and even close to 20 times what you want coming into the lake for the lake to stay healthy. And it's really been a key reason why we've struggled with the Eurasian water milfoil growth in this part of the lake. So pretty interesting test for this season and beyond, but based on our work on other lakes, we're confident that by taking a problem drain like this and really eliminating it from the equation as best we can in terms of its ability to dump nutrients quickly into the lake, that we're going to see a major turnaround in this part of the lake over the next season or two. So pretty interesting project. Sometimes when you identify a problem, you really have to start hundreds and hundreds of feet back from the lake and get creative with some cost-effective strategies like our filtration tubes and socks and these filtration cells, where we've got multiple layers of the filtration fabric and nutrient absorptive materials built into this cell, and then going back up to the top of the project where we had our deep dry well taking water that used to get to the lake and putting it into the ground, and our multiple stage stormwater filtration system that gets the water clean before it enters this final phase. So another great project, lots of learning. Give us a call if we can help you solve a drainage problem into your lake. Visit us at lake-savers.com or aerationtech.com, or give us a call at 269-383-3400. Thanks. See you next time with another great lake project.